Hi, in this video, I will be showing you problem number 15 of chapter 11 section 9. Find a power series representation for the function. Give your power series representation centered at x equal to 0. The function is f of x equal to ln of 9 minus x. In order to give a power series representation for ln of 9 minus x, we want to somehow link this to a geometric series. So we want to see whether integrating or differentiating a geometric series looking function, could it yield ln of 9 minus x? One more thing you want to notice that if a function has a power series representation with the radius of convergence r, then you can differentiate that by differentiating each one of the terms of the power series. And also you can integrate the function f of x by integrating each term of the power series representation of f of x. And both these differentiated series and the integrated series will have the same radius of convergence as the original function f of x. The interval of convergence might differ, but radius of convergence will be the same for the differentiated series and the integrated series as the original function f of x. So now we want to see, we will just check the ideas behind this. What is the derivative of ln of 9 minus x? So it is chain rule, so it is the outer derivative 1 over 9 minus x times the derivative of the inside, which is 1. So negative 1 over 9 minus x. So what we see here is derivative of the given function is negative 1 over 9 minus x, which by suitable manipulation can be considered as a geometric series. Right? So if I integrate this negative 1 over 9 minus x with respect to x, what I would get would be ln of 9 minus x. Derivative of ln of 9 minus x is negative 1 over l minus x. So if you inverse the process, if you integrate the right hand side, you get ln of 9 minus x. So that is the idea we want to bring in here. Which one looks like a geometric series? We want to relate the whole thing to a geometric series. So now, integral of 1 over 9 minus x. So I can write f of x, which is equal to ln of 9 minus x as negative integral 1 over 9 minus x dx. So it is negative integral 1 over 9, 1 minus x over 9. So we can pull the 9 out. Then that will be 9 times 1, 9. 9 times x over 9 is just x. You can pull the 9 like that. Now we also know on the side 1 over 1 minus x is nothing but the geometric series 1 plus x square and so on, which converges when absolute x is less than 1 or the common ratio is less than 1. This power series can be written as x to the power n varying from 0 through infinity, the common ratio to the power n, because the starting term is 1. So inside the integral, or you can remove the 1 over 9, then you can write integral of 1 over x minus 9 as 1 over 1 minus x over 9 looks like this with x replaced by x over 9. which can be written as a geometric series sigma x over 9 to the power n varying from 0 through infinity. So we are pretty much writing this geometric series as a power series representation inside the integral sign. Okay, now we are going to integrate each one of the terms. Because this is an integral problem now, so there will be a constant of integration. So it will be constant of integration. I'm just going to place it in front. So negative 1 over 9. If you integrate each term, it is x to the power n over 9 to the power n. So it will be 1 over 9 to the power n, which is a constant. Then x to the n plus 1 over n plus 1 when you integrate that expression inside the sigma sign. So we can write this as c times sigma n varying from 0 through infinity 1 over 9 to the power n plus 1. If you move the 9 inside, x to the n plus 1 over n plus 1. We can write this f of x equal to ln of 9 minus x, and the sigma notation in a slightly different way. Instead of starting from 0, if you move the index to 1, if you make it to 1 through infinity, if you move this index to the right by 1 unit, you have to move this index, the exponent, to the left by 1 unit, the terms inside the sigma symbol. So, inside you will get 1 over 9 to the exponent n, then x to the n. Every n, the exponent moves to the left 1 unit, divided by n. Now we want to determine what this constant c is. So let's substitute x equal to 0 in this relation. Substituting x equal to 0. So we get ln of 9 minus 0 equal to c minus, because of the x to the power n involved, everything will become 0. Now the constant of integration is just ln of 9. So we get the series to be equal to, with c replaced by, so the series becomes f of x, which is equal to ln of 9 minus x. C is ln 9 minus sigma n varying from 1 through infinity 1 over 9 to the n x to the power n over n. Now the radius of convergence is pretty much same as the radius of convergence of the power series for the geometric series. So the series converges when absolute x by 9, the common ratio is less than 1. So the series converges when the common ratio absolute x over 9. For this part, the common ratio is x over 9 is less than 1. Or when absolute x is less than 9. So the radius of convergence for this one is going to be 9. So there are two things asked in the problem. Now what is the power series representation? So when you write out the power series representation, ultimately turns out to be the expression in LO. Keep in mind we have to determine the constant of integration. That turns out to be ln 9 here. And then because it's a power series representation, it always makes sense to mention where the series converges, determining what the radius of convergence is, which we mentioned as r equal to 9. Hope this video helped.